Hello friends. So after covering the different numericals on Laplace transform, let us see one more numerical, that is nothing but the differential equation. So here in this video we are going to see how to solve the differential equation by using Laplace transform and by using the given conditions. So here we have to solve this d square y by dt square plus 9y equal to 18t where two conditions are given. So guys, here first of all we have to observe that the given equation is a differential equation. So whenever we solve any differential equation, we get the value of dependent variable in terms of independent variable. It means my final answer is gonna be y in terms of t. Now to solve the differential equation, there are many methods which you have learned in the lower standards, but as we are in the Laplace transform, we have to use the method of Laplace transform to get the solution of this differential equation. So guys, what we are going to do is we are going to follow certain steps. So in step number 1, we are going to apply Laplace transform on both sides. So here I'll say so this will give us now Laplace transform of d square y by dt square. So this is the second order derivative of y. So the question is how to get the Laplace of this. So guys, to find out this derivative term, there is a property called as Laplace transform of derivative. So I'm going to use that property. So here is that property. So if I want to find out Laplace transform of f double dash of t or y double dash of t, which is nothing but second order derivative of y of t, then this is the property. So I'll be using this property to get the answer. So I'll just copy down this property over there. So I'll get plus this term is 9 times Laplace of y equal to 18 is a constant, I'll take it outside, and Laplace transform of t is 1 upon s square. Now guys, here I'll put the values. So value of y of 0 is given as 0, so this term will become 0. So I'll take all Laplace of y terms together, so this will become s square plus 9, and Laplace of y is common, that is L of y is common. Then y of 0 is 0, so this term is 0, and for y dash of 0 we'll take the value. But unfortunately the value of y dash of 0 is not given. So now question is how to get the solution in this case, because here the value of y of pi by 2 is given, but in the equation actually we are getting the term y dash of 0. So guys, in such cases what do we do is, for temporary time I'll assume that value is equal to a, since this value is gonna be some constant. So what we'll do is we'll solve this and we'll get the value of a, and then we'll put that value over here to get the final answer. So I have substituted y dash of 0 as a, and right hand side is 18 upon s square. So this will give us s square plus 9 into Laplace of y equal to 18 upon s square plus a. Now this s square plus 9 is multiplying this Laplace of y, which will go on the right hand side and will divide these two terms. So we will get Laplace of y equal to 18 upon s square into s square plus 9 plus a upon s square plus 9. So guys, what I have done is I have taken this s square plus 9 on the right hand side in the denominator, and now we got value of Laplace of y. But as per the question, we should get value of y in terms of t, and for that reason I have to take this Laplace on right hand side, which will become Laplace inverse. So it means y is nothing but inverse Laplace transform of this 18 upon s square into s square plus 9 plus a upon s square plus 9. Now, the inverse Laplace transform of this a upon s square plus 9 is straightforward. We have a standard formula. But here, there are two terms in the denominator and we do not have any standard formula for this. And that is why we have to use the method of partial fraction for this first term. Now guys, there are two methods of finding partial fraction. One is you have to follow this whole process of partial fraction, or you can use the adjustment method where I'll be doing few adjustments over here to get the partial fraction of the first term. So let's see how to do that. So here L inverse as it is, we'll write these terms as 1 upon s square minus 1 upon s square plus 9. Now guys, let's say if we do the cross multiplication over here, we should get this term. So let's check what we are getting. So this will become s square plus 9 minus s square. So s square and s square will be cancelled. We will get 9 upon this s square into s square plus 9. It means we are getting denominator, but in the numerator we are getting 9, whereas in our function the numerator is 18. So to get 18 we will also multiply by 2. So this 9 into 2 will become 18. And guys, here we got the partial fraction. So you have to use such tricks to find out the partial fraction so that it saves your time, because again partial fraction is gonna take your one page. Now the second term is a upon s square plus 9. Now guys, let's find out inverse Laplace transform. So this will give us 2 outside. The inverse Laplace transform of 1 upon s square is t minus inverse Laplace transform of this is 1 by 3 sine of 3t plus a outside, and inverse Laplace transform of this 1 upon s square plus 9 is 1 by 3 into sine of 3t. So let's take this sine 3t terms together. So we will get 2t as it is, and this is sine 3t common, so plus a upon 3 minus 2 upon 3 into sine of 3t. And guys, this is nothing but the value of y, that is y of t. Now guys, here in the value of y of t, we got one unknown, that is a. So we cannot keep unknown in the final answer. So to eliminate that unknown, here in the question we have one more condition, that is y of pi by 2 is 0. And that is why guys, in this equation, let's call this equation number 1, I'm gonna put t equal to pi by 2. So I have value of y of pi by 2 and we can get the value of that a. So here I'll say put t equal to pi upon 2 in equation number 1. So we will get y of pi upon 2 on LHS equal to, this will become 2 into pi upon 2, 2 cancelled, so we will get pi plus a upon 3 minus 2 upon 3 as it is. Here I'll get pi upon 2. So guys, sine of 3 pi upon 2 is negative 1. So we will get a minus 2 by 3 into minus 1. Now y of pi upon 2 is given as 0. This is pi. This is negative a minus 2 by 3. It will come here. That will become positive a minus 2 by 3 equal to pi. It will go here. That will become a minus 2 equal to 3 pi. And we will get a equal to 3 pi plus 2. And now guys, we are going to put this value of a equal to 3 pi by 2 in equation number 1. So this will become 3 pi plus 2 upon 3. So here we will get y of t equal to 2t plus 3 pi plus 2 upon 3, and this term as it is, that is minus 2 by 3 into sine of 3t. Now here we will get 2t plus 3 is the denominator which is common, and in the numerator we will get 3 pi plus 2 minus 2, 2 to cancel, so we will get 3 pi upon 3, that is pi, into sine of 3t. And guys, this is nothing but value of y as a function of t. So here we have solved the given differential equation by using the conditions and the inverse Laplace transform. So I'm sure that you understood how to take the unknown as a, and then how to evaluate that value of a and get the value of y as a function of t. So share this video with your friends so that they can also get the knowledge about the Laplace transform and this different type of variations in the numerical. Thank you very much.